picking up yesterday on part 2 of Objective 16, and so really we're going to kind of put it all together today, and we're going to be able to find missing angles. We're going to be able to find missing lengths of sides. Any questions so far about where we're headed? All right, so I know we did this example yesterday in example 5. I wanted to stop there, let you practice what we've done so far before we head into this next part. I want to redo this example. I know you already did it once yesterday, but just to refresh your memory, I'm going to go back through it, and then I'm going to show you another way. You know, we keep talking about, like, I need you to be able to see the whole picture, because for those of us who are going to end up taking the final exam, when it's comprehensive and I give you a problem, you know, I need you to be able to pull from everything that we learn and find one way, shape, or form to find the answer. Does that make sense? So what we're going to do is we're going to go back and relate it to the unit circle today. So yesterday when we started this, you can't solve for A and B. You can't plug into the Pythagorean theorem because what? There's two missing sides. Okay, in order to do the Pythagorean theorem, you got to have two sides of a right triangle and find the missing third. Okay, so what you're going to have to do is you're going to have to use this 30-degree angle to help you. So if we found A first, what's the relationship between the A, and I'm not going to use the B right now because I don't have that, so I'm going to use the 12. What's the relationship between the A and the 12? So we have, and we know opposite of our hypotenuse would be the sine. Okay, so we can say that the sine of 30 is equal to the opposite, which is A, over 12. And then you can solve for that. And we did solve for that. We times by 12, and so we did 12 times the sine of 30. Make sure your calc is equal to A. And you can put that in your calculator as long as your calculator is in degrees. Do you understand that? Okay, if I'm going to enter in 30 as degrees, then I got to have my calculator in degrees. Okay, and you did that and you got what? 10 point. Was that not the sine? This one was 6. This one was 6. The sine is 6. Okay. So when you did that, you end up with 6 is equal to A. Okay? So I want to look at another way to do this. Let's go back. We know this is going to be equal to 6. Let me take this back 2 seconds. And there's another way. Now, if it has like a 30 or 60 or 45 degree, we know, like based on the unit circle, what is the sine of 30 degrees? Pull out your unit circle right now, and I want you, what's the sine? Which coordinate? It's the y. Okay, I want you to go to your unit circle, get you a clean sheet. You should have a good copy of the unit circle somewhere in your notes. Okay, and tell me, first of all, what's the terminal point at the sine of 30? What's it? If I go to 30 degrees, what's my terminal point? Square root of 3 over 2 and 1/2. Okay, so which one would be the sine? 1/2. So if it is a 30-degree angle, we know that the sine of 30 degrees based on our unit circle is equal to 1/2. And then you can still solve it. What's half of 12? Does that make sense? Hey, okay. You can put it in your calculator, 12 times the sine of 30, and it'll give you 6. Or if it is a point on your, now when would you have to use the calculator? When it's not a point, like a clear point. I say clear points on the unit circle, like if I give you 56 degrees. Then you just need to put it in your calculator like I showed you yesterday. But if it's a 30 or a 45 or a 60, then you can use your unit circle points and solve it that way. So let's look at what B would be. I want to look at it based on what we did yesterday, and then I want to look at it using the terminal point. Okay? So what's the relationship of 30 degrees to the B and the 12? It's adjacent and opposite if you make this your right angle. Okay, so what would that be? That would be cosine of 30 is equal to the adjacent, which is B over 12. So far, so good? Yesterday, to solve this, we times by 12. And so what is 12 times the cosine of 30? 10.3392 30 something, okay, is equal to B. So that's what we got yesterday by putting it in the calculator. Let's look and see what it would be if we used our terminal point and worked it algebraically without the calculator. Okay, you ready? Oops. Come on, give me an eraser. Eraser. All right, so we know the cosine of 30 is what? Square root of 3 over 2, and we're going to times that by 12, right? And that's going to give me B. So if I worked this out, what would that be? 12 times the square root of 3 over 2. Simplify it. 6 square root of 3. Oh, so we know that B would be equal to 6 square root of 3. Now that doesn't look like what we got yesterday. We got 10.93 something something 39 something 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 something. Why is it the same thing, Julie? What did you do? So multiply 6 times the square root of 3, it's the same thing. Do you understand that? So put that in your calculator. 6 times square root of 3. What do you get? You get 10.39, whatever that decimal was. Okay? So let's continue on with this. Remember, if I give you a 30, a 45, or a 60, you can use your unit circle and solve it by hand using your terminal points, okay? Or you can put it in your calculator. I'd like you to do both right now. Why is it good to do both? Right, remember yesterday we talked basketball? I said if I only can get the ball in the hoop one way, from one angle, I'm not going to be a very good ball player. But if you know lots of different ways to do it, then in any situation, you can find one way to get the job done. Do you understand? And sometimes certain situations, certain ways are better or easier than the other ways. Okay? All right. So, yeah. Let's look at this first. Okay? I'm going to deviate a little bit and then we'll come back to the triangles. So based on what we just talked about, could you work this out using your terminal points? Yes, because it's the sine of 45 degrees and the cosine of 45 degrees, okay? So here's what I'd like for you to do. I want you to work it out using your terminal points, and then what do I want you to do? Just put it in the calculator. Put in sine of 45, square it, plus cosine of 45, square it. And I want you to see if you come out with the same answers. Okay? All right. So, which way you want to do it first? Let's do it. Let's use it with the unit circle first. Okay? So, what's the sine of 45 degrees? What's my terminal point at 45 degrees? What's the actual point? Square root of 2 over 2 and square root of 2 over 2. Right? Positive, positive. All right, so we're going to put in square root of 2 over 2, and we're going to square it, plus the cosine is going to be square root of 2 over 2 and square it. All right, so when we do this, that makes 1/4 plus 1/4, which is equal to 1/2. Any questions on that? Just kidding. All right. Those cancel, and I get 2 over 4, which is 1/2. 2 over 4, which is 1/2, and that equals 1. Better? Thank you. Okay, so any questions when you just put it in your calculator? Parentheses, sine of 45 squared, plus parentheses, cosine of 45 squared. You should get 1. Okay, any questions about that? All right, so you try this one. Try it both ways. Okay. Half of a half? What's half of a half? That's what it is. All right, so I'll come look at it. So I want you to take a look. You just have to keep cautious, careful, conscientious. You got to keep track of what's your sine, what's your cosine, which one's 30, which one's 60. But the sine of 30 and the cosine of 60 are both a half. And the sine of 60 and the cosine, and the cosine of 30 is square root of 3 over 2. And so when you multiply them, 1/2 times 1/2 is 1/4. Square root of 3 over 2 times square root of 3 over 2, square root of 3 times square root of 3 is just 3. 2 times 2 is 4. And when you add 1/4 plus 3/4, you get 4/4, which is equal to 1. Any question? It could be, but probably not. I mean, this right here, guys, this is not a big skill right here. Like, just putting these in. Now, when we flip to, I think we're almost there. Yeah. This is like what I this is called putting it all together. Okay? There's one other thing that you need to know to put it all together, and you're going to use several different things. You're going to use the Pythagorean theorem. You're going to use your sine and cosine abilities and your trig functions. But there's one other thing that you need to know, and I'll get you started on this. So I can't go directly, when I say solve a triangle, by the way, when I say solve this triangle, and I'm going to say that on quizzes and tests, I'm going to say solve the triangle. That means find all the lengths and find all the angles. Okay? What's one more thing we know about, and this is coming back from geometry, about angles and triangles? They all add up to be 180. Okay? So let me just let you think about it for a minute. Start finding anything you know using your geometry skills. Okay? And using your sine and your cosine, and then maybe even your Pythagorean theorem, and kind of putting it all together. So I'll give you like 4 minutes. Let's roll. Okay, so we know, first of all, everybody listen, put this all together. Okay, we know 3 angles in a triangle. Like I'm gonna give you any little piece of it, and you're gonna have to start making, like, okay, I know that 3 angles in a triangle add up to be 180. Well, if I know this is 90 degrees and this is 45 degrees, then that's going to make 45 degrees. Okay? All right. Now we know, we talked yesterday that, the side opposite the largest angle is going to be the largest side. The side opposite the smallest angle is going to be the smallest side, right? But what do we know if the 2 angles are equal? Then the 2 sides are equal. So we know this leg is 16. Then, based on what we know from yesterday, we know that we can just go through the Pythagorean theorem. So we don't really have to use our sine and our cosines for this particular problem, but will there be problems that we have to use our trig functions? Yes. So you have to look and see. It's kind of like a big puzzle. Like, what do you have? What can you use? What do we know? Okay. So we can do a squared plus b squared is equal to c squared. Okay, and so that will be 256 plus 256, which is equal to c squared. That's going to be 512, which is equal to c squared. And when I take the square root, then it never says that's really big. You can't leave it the square root of 512. I will take points off for that because you know better than that. You can factor this down into 256 times 2 and then 16 times 16. And you can keep going into 4 and 4 and 2 and 2, but I'm just going to go ahead. I've got a pair of 16s here. So what is 6? That comes out as a 16 times the square root of 2. And so there is your hypotenuse. Okay, and so you have now solved the triangle because you found all the angles and all the sides. Okay? You can't break him down once he's on the outside because he's free. You can break those down. I could have kept going into 4 and 4 and 2 and 2 and a group of 2s and a group of 2s and then done it again and then done 2 some 2 some 2 some 2 and gotten 16. But when you have a match, you can just take that match out. Does that make sense? I didn't show y'all that in Algebra 2 because I didn't know if you would be ready for it. But I feel like you might be ready for that. Yeah. Okay. So let's make this the right angle. Okay. And let's see what we know. Any questions so far? All right. So first of all, we look at you say, what's anything I know? Like you got to pull from like 10 different things to be able to eventually solve. Okay? So what's one thing I know? All the angles equal 180 and I've got 2 of the angles. Okay? So what's this angle? This is 22. Okay? Then you need to label your sides. You can do X and Y, you can do alpha and beta, you can do A and B, you can do whatever you want. Okay? What do you want to label them? A and B. Does it matter? Julie's, I figured you'd be pretty picky on what you want. I say that with love. So, the question is, do I use 68 or do I use 22? Does it matter? It does not matter. Like, for example, some of us, let's say we use 68. So, let's solve for A first. So, what's the relationship of A to 68? It's the opposite. Does everybody understand that? What else do I have? I have the hypotenuse. So, what's the relationship of opposite to hypotenuse? That's the sine. So, you could say the sine of 68 is equal to the opposite A over 1,000. How many did that? Did anybody use 22? Would it be the exact same thing? Remember the whole exercise we did yesterday on how I had you find the sine of alpha and the cosine of beta, and you realized it was going to be the same thing? That was preparing you for this right here. When we really put it together, that would it be, what if I use 22? What's the relationship of A to 22? It's the adjacent. So if you found the cosine of 22, and you could do the A over 1,000, that's going to end up being the same thing. Do you understand what I'm saying? Yes? So it does not matter which one you pick, okay? I'm going to do this one just to show you, because everybody else did the sine. I'm going to do the cosine of 22 to show you that it's going to be the same thing. Do you understand? So it does not matter whichever angle you pick. You can't just randomly pick sine or cosine. Like, you got to know which the relationship is. So if I pick 68, we know the relationship would be opposite over hypotenuse, which would be sine. So if you're going to pick 68, you got to use the sine. Okay, you can't do cosine. Do you understand that? Okay, so if I solve this, I'm going to times both sides by 1,000. And so when I put that in my calculator, what do you get? I don't know that I have degrees yet or not. Yep. So I'm going to do 1,000 times the cosine of 22. What do you get? Round it to the nearest, let's do 2 decimal places. So A is equal to 927.18. That's your A. And that's what I got doing this one down here at the bottom. Did you get the same thing when you did the sign? Okay. So then, how do I find B? Which angle do you want to use? Do you want to use 68? Do you want to use 22? Use 68 again? Okay. So what's the relationship of B to 68? It's adjacent. It's beside of it. So adjacent is going to end up being the cosine because it's adjacent over hypotenuse. So when I times by 1,000, so I'm going to do 1,000 times the cosine of 68. And that's going to give me what? 374.61. Any questions on? So the last example, this is where I feel like you're going to get confused because you're going to say, I don't know what to do. Like, when do you use the Pythagorean theorem? When you have what? 2 sides, 2 of the 3 sides. Do you understand? So on the last example, we had 2 of the sides. So I just used, would it be okay if I did, like, I don't know, to find this missing side, if I didn't do the Pythagorean theorem? What if I did the sine of 45 is equal to 16 over C and solved for C that way? Would that be okay? So can I just show you really quickly if I go backwards? Because I just want to show you, like, that as long as you're using your trig appropriately, you can use your trig. You can use the Pythagorean theorem. You can use that the 3 angles add up to be 180. It's just whatever you need. So, you know, on the last example, we did the Pythagorean theorem, correct? But if I wanted to, let's use this angle. And I want to find this right here. You follow me on this? So I could do the sine of 45 is equal to the opposite, which is 16 over C. Now, Allison asked a good question. How would we solve for C for this? So I told her, Lee asked the same question too. So that's why you both asked the same question, so I want to go over it. So everybody says, I don't know how to solve this. Sure you do. Ooh, yuck, gross, disgusting, nasty fractions. Get rid of them. We're going to multiply both by C. With me so far? So this becomes C times the sine of 45. What happens to the C's here? They cancel, and I get 16. So then what would I do to solve for C? I'm going to divide by the sine of 45. So in your calculators, you could do 16 divided by the sine of 45, and it's going to give you a decimal, 22.63 something, okay? But we ended up with 16 times the square root of 2. What do you think is going to happen if I multiply 16 times square root of 2? It's going to be the same thing. What if, would this be a good one to use my unit circle on? What if I use that? What is the sine of 45 degrees? So check this out, 16 over 1 over the square root of 2 over 2. You with me so far? This is going to give you what? 32 over, okay, then if I rationalize it, I'm going to end up with, I want to get where you can see, 32 times the square root of 2 over 2, and then if I simplify it, what will it become? 16 times the square root of 2, which is what I got over here. Do you see what I'm saying? Like, there's like endless possibilities to get the right answer as long as you're doing it correctly. It's always that stump. You got to do it right, but you can do it different ways. So it's very possible that Seth do it, you know, by the Pythagorean theorem, and Allison do it using the sine of 45 is equal to the opposite over the hypotenuse, and then, you know, you guys, Andrea can do it the same way, except she puts it in her calculator, and Allison does it using the unit circle. And then we all come out with the same answer. Do you understand? Sort of? Have I said too much? Okay. So we're going to go back to what we did yesterday. I'm just going to let you try some practice and let you sit and try to figure some of this out. Okay, I think what I would like to do, can I take this in chunks? instead of listing out like a whole set of problems. So I want you to look at on page 193. Right now, I only want you to do 9 through 14. Okay, so for right now, I only want you to do 9 through 14. Okay,